So today we're going to go over Euler's method, which is a way to approximate the value of a function at a specific index. Now, Euler's method is not very accurate. However, the AP test does ask you to use it sometimes. And so let's go ahead and look at this equation that can be used to approximate a new value. It states that the new value of y is approximately equal to the old value of y plus the slope times delta x. Now, delta x is equal to the final value of x minus the initial value of x over the number of steps. And they will tell you the number of steps, and it really just means however many times you're going to approximate a new value. And so what I'd like to do is I'd like to create a graphical organizer. Your leftmost column is going to be titled x. And if you start off with f of 0, then you'll put 0 here. And then you may increase to 1 if delta x is 1. And this second leftmost column is going to be titled y old. And now you're also going to have the slope column. And this is the column in which you calculate the slope. And it's usually going to be in terms of y and x. And over here is the column where I like to approximate y new. And I always like to recite the formula, or at least write it down. And of course, at the end of all of this, after you've approximated it, the value, you're going to have to remember to put the approximation sign, because this, as I said earlier, is not very accurate, but it is useful. Okay, so this is example problem 1. This is the only problem we're going to go over today. But essentially, this problem is asking what f of 3 is equal to. And it's telling us that dy dx, the derivative of y with respect to x, is equal to 3y plus x. It tells us that f of 0 is equal to 1, and it tells us to use 3 steps. So first things first, we're going to try to find delta x. Now, delta x, as I said earlier, is equal to y final, which is 3, minus y initial, which is 0 over 3. So delta x is equal to 1, and that essentially represents what x will be increasing by. So let's create our organizer. It will most likely look terrible, but let's go ahead and divide up these into columns. Okay. Now over here is going to be our x. Now, what is x in this situation? Or what is our first x? As I said earlier, in the problem, it says that it's 0. Or sorry, it's 0. So x is 0. Y of old at f of 0 is equal to 1. So y old is 1 at index 0. Now, what is the derivative? Or sorry, what is the slope at any index? It's 3y plus x. So in this situation, the slope is just going to be 3. Now, what is y new? It's y old plus max, if you'll remember that equation. So we can just fill these in. It says that 3 plus max, which is just 0, or sorry, which is 3 in this situation. So y new is equal to 4. However, we have to do this a few more times. It asks us to use 3 steps. So our new x will be 1. Our new y of old will be our y of new from the last approximation. So that's going to be equal to 4. And now this is equal to 15, because it's 13. 3 times 4 plus 1. And we can approximate our y of new, which is 13 plus 4 plus 1 times 13. So we end up with 17. Our x is going to be equal to 2. Our y of old is going to be our y of new from the last approximation, which is 17. Our dy dx is going to be 3 times 17 plus x, which ends up being 53. And so now it's asking, now our new y new will be 17 plus 57, which is 70. And now we can say that at f of 3, our y value is 70. So we can state that, I probably should have left room, but we can do it up here. We can state that f of 3 is approximately equal to 70, and that is our final answer.